All right, we're getting into section 5 practice lesson from unit 5, and this is triangle congruence and marking up triangles. So we're given a isosceles triangle with the given information that CWN is an isosceles triangle, and R is the midpoint of WN, and it comes down right from the vertex. All right, so R is a midpoint of WN. R is a midpoint of WN. So that means that W and WR is congruent to WN, because that's the definition of a midpoint. So which sides of CRW and NRC are congruent? Well, that's WR and NR are congruent. Okay, and because because this is an isosceles triangle, right, and this comes down here and bisects this too, that means that these sides must be congruent as well, right? So we have this side and this side congruent. So we also have CW congruent to CN, because an isosceles triangle is a triangle that has two sides of the same length. And if this one came down and bisected this one, and this one wasn't, was the third one that didn't have the same length. So these two are the ones that have the third length. And then this one came down and bisected this one to make a perfectly the same two lengths of the same length. Okay, which of the triangles see are congruent based upon the given information? I think that's meant to say angles. Which angles of the triangles? It says I misread it. Which angles are congruent? Well, this angle and this angle must be congruent because it's an isosceles triangle, right? So angle CWR and is congruent to angle CNR. So these two angles must be congruent because this was an isosceles triangle, and in order for these to be the same length, these must have been the same angle. Definition of an isosceles triangle, right? And then because of the reflexive property, CR is congruent to CR. Right, that's the middle length here. It's the only one that's really going to help us because this is the only side or component of the triangle that is shared by both two triangles that we're trying to prove congruent. Okay, so because we have a side over here, we have an angle. And a side. We have a side, an angle, and a side. We could have used the side angle side postulate, right? Or because we have a side, the third side here, and the side, we could have used the side postulate. Either one of those would have worked. Okay, so moving on to this one. This one was a little bit more complicated. When I say a little bit, it's actually I don't think they meant to make it this complicated, but I think they overlooked a given that they should have given us. So I'm going to go ahead and start marking it up. So DKF, so DK, so this is angle DKT. So DKT is this angle, and then TFH, TFH, the same angle they just used. Different starting point for the legs. Okay, is this angle. KD. KD is this big long angle here. So I'm gonna kind of do this so that it's obvious which one we're talking about. KD. I don't know how obvious that is. Maybe on there, make it more obvious. Yeah, that's more obvious. KD. and then it's going to be congruent to DF. That's congruent to DF. Make that 2, just because it's not lined up with my single one. Okay, and then it says DTK. DTK, this whole one right here, this big one, is congruent to FTD. FTD. I'm going to make this one, I'm going to make it smaller, make it congruent to this. So this angle and this angle are congruent. Okay, so I'm trying to talk about this triangle right here. It's going to be a purple triangle. Is probably what I'm trying to do. Oh, so I need to mark up XK. XK. It's probably going to end up being a different triangle. So XK and XK and L. It's probably going to be LF. Yep, LF is that one. And then DY is perpendicular to K. I'm going to make that one green, make it stand out a little. And then DY is perpendicular to KF. That's all it tells me. Okay? Alright, so let's go ahead and start marking up what we know. Okay, so KD and DF, that's KD and DF, those are my purple 2s. DTK, DTK is congruent. And so this is my double angle. And then my single angle is probably good. So I have an angle, and then an opposite side. Right, so this is going to be angle. My single angle was DTK. Or I already used these ones. This is my double angle, my double, and then my single DKT. Angle DKT, and angle TFH is what they called it at the very beginning. It's my single angles, right? These angles here, right? I'm gonna call that my blue single angle right there, right? Sorry, not blue, my purple. That's purple actually. My purple single angle right there makes this triangle TK or TDK, triangle TDK, congruent to triangle TDF. So I'm going to go ahead and solidify that. TDF. Okay. Now recognizing that this is also my purple triangle, hypotenuse. Okay, or not hypotenuse, shared third length. Okay, so I'm going to make this my third angle here, and this is my third angle here, and my third length here of that triangle, because congruent parts of congruent triangle are congruent. Okay. Which angle shows this? This was the angle side. Angle, because I have an angle, another angle. This was my my single angle that I had, and then I had a side, an angle side, because one of these angles was opposite the other angle, and that was my angle side one. Okay, and then this is where it gets a little hairy. Okay, what postulate can be used to show that DKK, DKK dkx. So dkx, this is an outer triangle. dkx is congruent to dfl. dfl. So I think they thought that we could just go ahead and say that because this was perpendicular, that this is perpendicular. Well, they never told us that these two lines were parallel, right? So we can't say that this line here is parallel and that these two line segments are the same. So we got to do some work here. So in order to do this, let's get to work. So first thing we need to do is we're going to use this triangle here, right? This is a whole. These here are a whole line. This is a line, right? One whole line. So I can say that this triangle, these angles here, are congruent because this is a straight line, and I know that supplements of congruent angles are congruent. Okay, so I know that angle, let's say what number 1 here, angle KTY is congruent to angle FTY. Angle FTY. All right, so I know that. All right, so the next thing that I know is that I know that TY, I know that too. I'm going to say supplements of congruent angles are congruent. I'm just writing that down there to remind you. Okay, so the next one I'm saying is TY is congruent to TY. Right, and that's reflexive. I'm going to keep that just a single. I'm going to say that's the second one. Okay, so now I have a side on each. I have an angle on each, and I have a side on each. So I can say triangle KTY is congruent to triangle FTY. All right, so these two triangles are congruent. Okay, so then I can say all of this stuff. All of this stuff is true. All right. So I marked all that stuff up as true. So all of that stuff that I just put as true because of the congruent triangles. So for corresponding parts of congruent triangles are congruent. All right. So now I have, I'm not even sure if I'm going to use that or not, but I just marked it up. Okay. So now that I have this part of this triangle here, right? I have this triangle here. Use like a blue triangle. Okay. So I'm going to use this here and this here. What I really need to know is that I have this whole part right here, right? I have this whole angle. Right, the next thing I'm going to do is I'm going to say 5. This next step is I'm going to say that triangle or that angle WTD is congruent to angle HTD because of the angle addition postulate. Angle addition postulate. postulate, right? If I know all these add up to 180 degrees, if I take those away, right? Or if I take these two away, I have whatever's left. Those two angles are congruent, right? So these two angles are congruent. I know that number 6, rather, I know that dt is congruent to dt because of reflexive. Another blue line there. So then because I know that these, so now I can say, now I know that triangle, here we go, and I know that these two angles are congruent right here, so I'll say that triangle WTD, triangle WTD is congruent to triangle HTD because of the angle side angle. Okay, so these are now congruent. These two are now congruent triangles. Okay, and now because these are congruent triangles, I know that this is congruent to this. Okay, and I know that this angle is congruent to this angle. Okay, and all right, so, and I'm going to know that this angle is congruent to that angle, right? So, well, how do I know that, right? Well, I know that angle LDH is congruent to angle XDH because supplementaries of congruent angles are congruent. Okay, and here I know that there's a vertical angle here, right? And then I have a linear pair here, right, that are congruent. Okay, so and then over here too, and I can just say that I can also say that angle XWD is congruent to DHL, right? Because supplementals of congruent angles are congruent. All right, so now that I have that this angle and this angle are congruent, now I have a angle side angle, and I can say that these two triangles are congruent. Now I can say that triangle XWD is congruent to triangle DHL, so that I can say all the sides are congruent. So now I can say XD is congruent to DL because congruent parts of congruent triangles are congruent. And now because of that, I can say that KDY is congruent to FDL because of the side. That was a lot. All right. Holy cow. I don't think that's what they meant to do, but that's the way I had to do it because they didn't give us, if they had just said like XL was parallel to KF, then we would have been good to go, right? But they didn't. So you had to go through all that just to prove all that stuff. Okay, so which postular theorem shows that KXX is KXD? That's a KX, where's K? I'm sure I already proved this one. So K KXD. Oh, wait, did I prove this one? KXD, K. Oh wait, this was the side one. Which one was this? This is KDY. 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 What one did I use for this one? KDY. This was the angle side. Oh, I already proved that one. Yeah, so KXX. This was side. And then which partial did we do? TDF. TDF was TD. Where's F? TD. Where did F go? TDF. TDF. I already proved that one. It was like the first one I proved. Oh, it was angle side. Angle side. Did I misread this first one? Probably misread this first one here. KDY. KDY. Oh, KDY was the very first one. So the KDY would have been like, oh, we would have had, the first one was the purple, and then the length we had was perpendicular, and then we had the side of the leg. So that would have been hypotenuse leg. Sorry about that. I skipped ahead. Yeah, so the very first one, they said that this was perpendicular here, right? So that's 90 degrees, right? And it gave us the reflexive, and it gave us the hypotenuse right away. So that would have been an automatic hypotenuse leg, easy peasy. All right, I hope that helped. That was a marathon of the second one. But if you have any questions, let me know.